All right, everybody, let's go ahead and recap real quick. If you read through the text and that website that I linked, you would have seen that law of sines is best when you know side angle angle, or ASA, or SSA. If it is SSA, that is the ambiguous case that you saw in your textbook. And now we are going to talk about something called the law of cosines. And the law of cosines you use when you know SAS or SSS. And we'll review this at the end. But you can use them for any triangles, of course, but it won't work if it's, for example, law of sines won't work if only you know is side, 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 because you need to know angles in order to use the law of sines. So that's why I use one or some are better in certain scenarios than others. All right, let's keep going. So like I said, the law of cosines can be used for any triangle to find the side lengths and angle measurements. It does not have to be just right triangles, okay? And you're given this triangle ABC. Again, capital letters represents the angles, lowercase letters represent the sides. So, given triangle ABC, a squared is equal to b squared plus c squared minus 2bc times cosine, capital A. B squared is equal to a squared plus c squared minus 2ac times cosine of b. C squared is equal to a squared plus b squared minus 2ab times cosine of c. And you'll see a little pattern here to help you memorize, okay, to help you memorize the law of cosines. You'll notice that you're taking the cosine of the angle for the side that you are looking for, okay, or a squared, for the side that's opposite the equal sign. All right, and then you kind of see little patterns like BC, BC, AC, AC, and so on and so forth. All right, so let's take a look here. Just first example, let's use the law of cosines to solve for x. So we are solving for x, so let's say that x squared is equal to, okay, x squared is equal to 7 squared plus 12 squared minus 2 times 7 times 12 cosine of 65. So let's take a look at that a little bit deeper. X is the only angle we know. So we have side angle, side, right? The only angle that we know is the 65, which is across from the x. We are looking for x, so we are going to be taking the cosine of 65 at the end, all right? And then which other sides do you choose? Well, you only know the other two sides, right? So here's your leg squared plus your other, or side squared plus your other side squared. 2 times those two sides multiplied to each other, cosine of 65, cosine of the angle opposite this side that we are looking for. So it's a lot of calculator work and computation from here. So 49 plus 144 minus 168 cosine of 65. Throw everything into your calculator and then take the square root on both sides, okay? So pretty straightforward stuff. Let's jump over to number 4. We are looking for x. Okay, so we're going to do cosine of 52. So x squared is equal to 30 squared plus 23 squared minus 2 times 30 times 23. Cosine of 52. A lot of calculator work to get you down to x squared, and then take the square root on both sides. So one of the things I want to mention real quick is in your book, you can see the proof of the law of cosines. I like how your book, or actually I think it was that website that I sent you guys, said how it's not magic. It actually comes from manipulation of right triangles. So take a look at that proof of the law of cosines on page 417. So I want to go ahead and bring your attention to an SSS triangle like number 5. And for this SSS triangle, we are solving for x, the angle, okay? So we're going to go ahead and divert our attention to x. The side opposite x is 7, so we'll say that's 7 squared. Okay, 7 squared is equal to 11 squared plus 12 squared minus 2 times 11 times 12 cosine of x. All right, and we chose 7 because 7 is the side across the angle x that we are looking for. And it looks like we're going to have to do a cos inverse at some point, and that is always true when we're looking for angle measures. So I can go ahead and keep working through this, but I think you know where we're heading here. All right, and then we are going to go ahead and get it to isolation. So we're going to go ahead and subtract 265 on both sides. Divide by negative 264 on both sides. Take the cosine inverse on both sides. And pull out the calculator, round to the nearest tenth to get that x is equal to 35.1 degrees. All right, grab number 7 and try that one. See if you get the answer of x is equal to 53.8 degrees. And if you do, you have just solved an SSS triangle. And I'm going to create one for you, which is an SAS triangle, and work through those steps with you separately. So go ahead and try 7 now. Actually, let's go ahead and jump over, skip over homework 8 for now, which just kind of is repetition practice of law of cosine, and jump over to the lesson, law of sines and cosines, that kind of recaps everything. And I'll do an SAS triangle right here with example 1, okay? So let's take a look here. We have law of sines. We like to use law of sines when we're given 2 angles and 1 side, or else you can't really use it. So that's your AAS and your ASA. And we can also use it with 2 sides and 1 angle. That's our SSA. Law of cosines, best when you have 2 sides and 1 angle, and 3 sides. Okay. And tip here for when you are looking for 3 sides, or when you have an SSS, if you can, find the largest angle first. But we just did one where we didn't, so should be fine. Okay, it's just if you can. All right, so let's take a look at this SAS triangle in example 1. Okay, in this problem, we're basically going to use kind of a package deal of the law of sines and the law of cosines. And we want to find EF. We also want to find the measure of angle E and the measure of angle F. So we're looking for this value. Let's call that Y, actually. We're looking for Z here, measure of angle F, and let's call that X, okay? So we can't do the law of sines because we only know one of the angles, right? So we can't set up our sine proportion here, sine of A over A, sine of B over B. We can't do that because we only know one of the angles. So we actually have to use law of cosines to first find this side, okay? And once we know this side, then we can do law of sines because we'll know all 3 sides, and an angle, we'll have an SAS situation, and we can use, or SSA, sorry, SSA situation, there we go, and we can do law of sines. So let me walk you through this, all right? We know for a fact we can't use law of sines right now because I only know 1 angle, and I need to know more than 1 angle, or at least know more than 2 sides. So if you take a look at this, side 7 is across the angle Z, or angle F, which we've called Z, and side 10 is across angle E. So those 2 sides that you know you don't know the angle. So setting up that ratio of law of sines is going to take you nowhere. So let's call it law of cosines, and x squared is equal to 7 squared plus 10 squared minus 2 times 7 times 10 cosine of 132. All right. Working all that out, math with your calculator, you should get that x is equal to 15.6. So what did we just find here? Let me go ahead and erase all that. We found that x is equal to 15.6, and what is that going to allow us to do? Well, now it's going to allow us to do a law of sines, okay? Because we can use the law of sines to target one of the angles, especially if we take a look at, maybe let's say we want to find this angle, angle F, right? So we'll say, all right, sine of, we called that z. So sine of z over opposite side. So sine of z over 7 is equal to sine of 132 over 15.6. All right, so now we've set up the ratio, and we want to go ahead and do some solving. So do your cross products, and you should end up with sine of z is equal to 7 times sine of 132 all over 15.6 by the time you cross product, and then divide by 15.6. Throw that into your calculator to get, where's my calculator? Rounded approximately 0.3335. I'm going to take it 4 places there. And then sine inverse on both sides to get that z is approximately the sine inverse of 0.3335. So z is approximately 19.5 degrees. So that's your angle F. We already found EF. And then the measure of angle E, well, you know 2 out of the 3 angles of a triangle, so you can subtract that sum from 180 to get 28.5 degrees. So at this point, I would like you to pause the video and work through examples 2, 3, 4, and 5. And take some time to go through that, please. I'll go ahead and write the answers so that when you unpause the video, the answers will be there, and go through those, and then we'll take a look at some applications. All right, so you've got some answers for example 2 and example 3 on the screen. Take a look at those real quick. Check that with your answers. All right, and here's examples 4 and 5. You will have to do both law of sines and cosines in example 4 if you didn't catch that. There are the answers, and make sure you either check yours or use them now to try it on your own. You need to be able to do this on your own. All right, at this time, I'd like you to try the applications. You really just need to draw a picture. So for example, a wire 30 inches long is bent into a triangle with sides measuring 6 inches, 13 inches, and 11 inches. Okay. Find the measure of the largest angle in the triangle. Remember, the largest angle is opposite the largest side. So if we want to find the measure of that angle, we want to go ahead and do law of cosines, because it is SSS. And we'll go ahead and target 13. So 13 squared, so we can get cosine of x. So go ahead and try that one. You should get 95.2 degrees. Tia and Braden are standing 12 feet apart from each other on opposite sides of an in-ground swimming pool. They spot a pair of goggles on the pool floor between them. The angle of depression from Tia and Braden to the goggles, is 65 degrees and 28 degrees respectively. So Tia and Braden to the goggles, here are the goggles. One of them is 65 degrees, and one of them is 28 degrees for the angle of depression. Remember, horizontal looking down, horizontal looking down. Okay. We could easily find that third angle by subtracting from 180. And we can use that to find the direct distance from Tia to the goggles. Direct distance from Tia to the goggles. Obviously, this is going to be easy to find at 87 degrees. And we could do a law of sines to find the direct distance from Tia to the goggles. For an answer, set it up on your own. See if you get 5.6 feet. And I'm not going to tell you how to set up 8. I'm going to let you figure it out. But if you figure it out correctly, you will get the answer of 4.6 miles. At this time, I would like you to work through the odd problem and self-check before you jump into your Law of Cosines, MML. And this will be good practice for the Law of Sines and Law of Cosines quiz that you're going to have to take soon and very soon. So again, I would do the odds on this homework and self-check before you jump into your MML. Thanks for watching the video on Law of Cosines.